integrate sine inverse of x divided by the square root of 1 minus x squared dx from 0 up to root 3 on 2. Please kindly like, share, subscribe, and comment for us to build the mathematics community. For this integral, if we let I to be equal to sine inverse of x divided by the square root of 1 minus x squared dx from 0 up to root 3 on 2, then we can do this simple substitution. If we let theta to be equal to sine inverse of x, then if x equals 0, then we have theta to be equal to sine inverse of 0, which gives theta equals 0. And if x equals root 3 on 2, then we have theta to be equal to sine inverse of root 3 on 2, which gives pi on 3. Okay, so what do we do next? The next thing is to differentiate theta equals sine inverse of x with respect to x. Now, this gives d theta equals 1 divided by the square root of 1 minus x squared dx. If you want to understand how I did this differentiation, check the comment section or the description for the video on this. This gives I equals the integral from 0 up to pi on 3, then you represent sine inverse by theta and divided by the square root of 1 minus x squared, and here dx equals square root of 1 minus x squared times d theta. So in place of dx, we are going to put here square root of 1 minus x squared d theta, and here square root of 1 minus x squared will cancel square root of 1 minus x squared, and we have the integral from 0 up to pi on 3 theta times d theta. Okay, if we integrate theta with respect to d theta, we have theta squared divided by 2 from 0 up to pi on 3. Now, if we put in 0, everything there will be 0. And if we put in pi on 3, we have pi squared on 9 divided by 2, which gives pi squared on 9 times 1 out of 2. And we are going to get pi squared on 18 as our final answer. Please kindly like, share, comment, and follow me for us to build the mathematics community.